I have opened this particular software known as Octave. So Octave, when you install it, there are two modes. One is known as editor and another is known as command window. Okay, so if I press on command window, then you get something like this. So when you are learning the programming language, then you can use the command window in order to understand what is happening. Now, one of the main differences between uh, Octave or Matlab as compared to C, Fortran, Python, and all that is that over here you can first thing is that you can define your variables directly without stating what kind of a quantity it is. So, for example, I can say a equals to 2, b equals to 2.1 something, c is equal to some string, okay, a b c d something. So I can define variables. So if I call back a b c, so I can define quantities without saying what type of a variable it is. Okay, first thing. Second thing is that this particular software is really good for matrix for matrix calculation. In fact, Matlab stands for matrix laboratory. Okay, so for example, yeah, so in order to define a vector, I'm going to give you a very quick crash course. Okay, so let's say you want to define a vector. Okay, so there are two ways. So one is you can for example, I can say zeros of 3 comma 3. So then it creates a 3 by 3 matrix of entries zeros, or I can say ones of 3 comma 3, or I can say identity matrix. I am not sure if syntax is correct. Let me just check this. No, so here, okay, so fine, so let's say you defined it as something. Now if you want to, this is for initialization purpose. Okay, this is for initialization purpose. Now let us say you want 1 comma 1 entry to be 5, and then 1 comma 2 entry to be 10. So this is how you assign a particular entry. So whenever you are calling a particular entry in a matrix, the first you call it in this manner, where the first entry is the row number, second one is the column number. Okay, so now if I want to assign this to something, so I just simply say this and then it gives me the particular value. Okay, now if you want to multiply two matrices, so let us say okay, b is I think this is the identity matrix. Okay, so now if I want to multiply a times b, I just have to do that. Okay, so a times b will give me a only when a is identity matrix. So as you can see, it's a simple command in order to do the matrix multiplication. Similarly, let us say I want to do inverse. Okay, so inverse of identity matrix is the same identity matrix. So it is really easy to use the language, and then you can also do visualization using this. So for example, let us say x is some 0. So if I want to create a x range, x starting from 0 to 1 with increment of 0.1, then this is how I can create a row vector. Okay, and let us say y is equal to sine 2 pi x. Okay, so that is y, and then now I can plot x comma y comma red comma, let us say line width 2. Okay, so it creates the plot. So It's a really great software for very quickly doing analysis and then visualizing the results. The only way to learn the language is to go ahead and do some coding. Whenever you want to learn about something, there are two ways to do it for this software. If you know the command already, then you can say help. So if I say help plot, it will tell me what, how to do different things with plot command. But many times, even let's say you don't know what is the command to be used, then you simply go to Google and then you type, let us say, Matlab command for creating identity matrix. You don't know how to create an identity matrix, so you immediately do that, and you see the first one itself is okay. I is the function of n. Okay, and then another small tidbit when it comes to Matlab is that in Matlab the functions start with a small letter. So if I want to do, let us say, square root, okay, square root, the function name starts with small s, and the brackets you use are these kind of brackets. Remember that in Mathematica the function name starts with a capital letter and you use square brackets in whenever you are calling a function. Okay, so fine, all right. So I use this particular programming language, and now I am right. So right. So I am considering a bar with these properties. So actually this should be in pascals, huh? So I am using SI units everywhere. So I have considered a material with 200 kilopascals of Young's modulus, diameter of 1 inch, okay, length of 1 meter, and then K I am taking EA by L, and rho is okay, I have taken 7800 kg per meter cubed. Okay, so fine. So these are the same set of values I have considered for Mathematica. If you want, you can change this and that. So you can change this and that. Now what I am doing is, so for doing the plotting, I am considering for doing plotting, I am considering number of elements as equal to 100. Okay, so I'm going to divide x into 100 increments for the purpose of plotting. Okay, so from the Mathematica software I have copied the eigenvalues. Okay, so these were the three eigenvalues. Once you get these eigenvalues, remember what is omega. Omega was square root of lambda, or lambda was omega square, so I get that. And then after that I computed mm, this one's good, the frequency as omega divided by 2 pi. Okay, next after that the CJs. Okay, so there are three eigenvectors. So I got the three values for the CJs, and then using these you can compute the amplitude function. Okay, u01, u02, and u03. And once you have the amplitude function, um, the actual displacement field during vibration will be the u0 multiplied by cos omega t. Okay, and just so that you different modes will have the same level of amplitude. Somebody wants to say something? Okay, so to get the same level of amplitude, what I did was, I got, for each u0 I got something called amplitude, as 1 by max of absolute value of u01, and I am multiplying that to u01, u02, u03, so that the magnitude of the maximum value of u1, u2, u3 will be 1. Absolute value will be 1. Okay, so and remember that for the first mode the natural angular frequency is omega 1, second one omega 2, third one omega 3, and then after that I am plotting this function and plotting this function with some other parameters. Okay, so now let me run this program and show you the results for this problem.
That's the answer.
Yeah, just give it a second, let me sort of yeah, so this is the results. So the first mode of vibration is the shown by the green curve. Okay, so what are these curves? These are axial displacements as a function of position and time. So the time I am showing over here, so basically particles are vibrating axially, and each of them, so each of these curves, green curve, blue curve, red curve, each of them is a possible solution to the problem. Okay, the actual solution will be a linear combination of these three. It will depend on what was the initial condition. Now what are the observations that you can make from this particular figures? So the first thing is that the lowest mode has the mode with the lowest frequency, means the one which is oscillating slowly. This has this is a long wavelength mode, meaning if you look at the if you think of a mode as yeah, as having some sort of a wavelength, you can see that the wavelength of the lowest mode is the highest, and then as the mode number increases, the wavelength of vibration reduces. Okay, and the number of modes, so here we are considering a 3 parameter approximation solution, so we are going to get 3 modes of vibration. Okay, so 3 modes of vibration. So fine, I am going to stop it here and I'll have a small discussion with you. Okay, let me just stop the video.